Miss
am
Producer,
a physician
Unfiltered.
and
Woo!
I'm from a French origin, so I worked in France, in Paris, and I also worked for Doctors Without Borders in Africa and Asia. And I also had a private practice in Los Angeles, California, in the US. And now what I do, I write books, I do podcasts, I do speeches, I am a writer for Psychology Today. I'm very interested now. I do my passion because I'm very interested in astrobiology. I was interested when I was a little girl. I had fascinating dreams when I was 3, 4 years old about astrobiology, and I wanted to do this as my specialty. But then life came into play, and now I have time to address my passion, which is astrobiology. I also write books and do speeches with my husband, Dr. Eric Haseltine.
Take it away, Dr. Haseltine. Tell us who you are.
I'm a neuroscientist gone bad. I don't do bench neuroscience anymore, but I do applied neuroscience. I started off doing aerospace human factors. Then I moved over to Disney, where I worked on virtual reality. Then I worked in the intelligence community as a senior executive there for a few years after 9/11. I became a contractor after that, working again with Disney, and I started writing for Psychology Today, Discover Magazine as a popular science writer, and I now do speeches, write books with my wife, and that's pretty much what I do.
What would the conspiracy theorists out there say about you and your capabilities?
Well, I'd tell you, but
He would have to kill you. Oh, that's a problem.
We've got CIA, NSA, psychology, Disney. I mean,
Yeah, our
yeah.
life is wonderful. Very
Conspiracy theorists would
exciting.
have a really good time with you, Eric.
Well, and I
Okay.
appeared on a TV show
Right.
was run by this woman called Nicole Alibayof, and it was called Alien Files Reopened.
That's
That
right.
led to the book that Chris and I released last year called The New Science of UFOs, New Answers to Old Mysteries.
That's right. We were trying to figure out how plausible all these crazy arguments are out there, which is kind of what we're going to touch on today. So let's bring it in. Chris, can you tell us a little bit about what astrobiology is, and then segue into what panspermia, the concept of panspermia is?
Okay. So, astrobiology is a scientific field that studies the origin and future of life in the universe. And so, what is the origin of life on Earth? There are two different hypotheses. One is abiogenesis, which means that the original evolution of life and living forms come from non-living matters 3.8 billion years ago. Non-living matters like phosphate, sugars, nitrogenous bases. And but the opposite is the other hypothesis, which is panspermia. So panspermia, that theory argues that life did not originate on Earth, but instead evolved somewhere else in the universe, on different planets, maybe distributed by space dust, meteoroids, asteroids, comets, planetoids. So, and that's a fascinating theory because that brings two questions. First, can a journey on asteroid and meteorites be possible? Like, can organisms resist extreme cold, extreme long journeys, extreme long accelerations, extreme cosmic radiations? That's a question. The second question is, where does life originate from? Is there life somewhere else in the universe? So let me address those two questions. First, can organism resist extreme conditions? So there are extremophiles that can thrive in ice, in boiling water, in extreme acid medium, in extreme alkaline medium, and in the water core of nuclear reactor, and in toxic waste. Amazing. One of them is called Deinococcus radiodurans, which is a bacterium, an extremophile, one of the most radiation-resistant organisms known. And it can survive cold, dehydration, vacuum, acid, and it has been found to survive for 3 years in outer space, based on studies conducted by the International Space Station. Now, there are also species of tardigrades. The little tardigrades, they're on Earth, they're little bears with 8 legs, they're about 1 millimeter long, and they're found on moss, on fresh or seawater sediment. And those little tardigrades, they can sustain 16,000 Gs, 16,000 times the force of gravity. When a human will be killed with just 12 Gs, 12, 15 Gs, they can sustain 16,000 Gs. And they can survive 30 years at 0 degrees Fahrenheit and 10 years in a dehydrated state. And they have survived 18 months in the vacuum of space outside the International Space Station. There are also fruit flies. Did you know that fruit flies are extremely tough? They can survive, they can withstand 17,000 times the force of gravity. And they're roundworms, they're parasite that can survive 80,000 times the force of gravity. And in 2023, it was reported that an individual roundworm has been revived after 46,000 years in the Siberian permafrost. Talking about extreme conditions, did you know we have found life near the bottom of our ocean, 5 miles below the surface, near hydrothermal vents? How can that be possible? That huge pressure of 5 miles of water, cells would be crushed, and yet there's the Mariana snailfish that can live there in the Mariana Trench, 5 miles below the surface. Now, what about organisms that can survive, have extremely long lives? Well, some species of jellyfish are biologically quasi-immortal. There are also researchers from the University of Tokyo that have found on Earth microbes alive in a sealed 2 billion-year-old rock that was last month in northeastern South Africa. Amazing. So now so you see, there are organisms that can survive long travels and harsh temperatures and harsh conditions. Now, are there signatures of life outside our planet? Yes. In meteorites, there has been evidence of fossils of microscopic life forms. And there are interesting products of life forms that are called methane gas and also dimethyl sulfide. Where have we found methane gas? So methane gas on Earth, they're only produced by life forms. But on Mars, we have detected methane gas that's emitted more during the summer of Mars and less during its winter. We've also detected on Mars CO2, argon, nitrogen, and traces of oxygen, and also water in the atmosphere of Mars. Did you know that Mars has a lot of Mars quakes, about 4.5 level quakes from former volcanic areas that erupted 10 million years ago? It also has caves and big lava tubes. And we think that those caves and big lava tubes are a shield from cosmic rays. And it also would keep the temperatures inside the tubes constant with more humidity, which would be perfect for life forms. We've also seen deep craters on Mars, with on the crater walls, from mid-wall to the bottom of the crater, long shining streaks during the summer of Mars. And some researchers think that those shining streaks could be water coming from deep aquifers. So the question is, where is the methane coming from? Where is the water coming from? Where are those coming from? So we need more studies. We need we need the Curiosity rover to go there. Curiosity rover, by the way, detected 1 month ago molecule chains containing up to 12 carbon atoms linked together which could be part of fatty acids in a 3.7 billion year old rock on Mars. So they could be live on Mars that we haven't uncovered yet. But where else in the universe have we discovered methane? Well, we've discovered methane on Jupiter's moon, Europa, on Saturn's moon, Enceladus, uh, and those have like geyser-like jets that spew water vapor and ice particles from a subsurface salty ocean. And those have also hydrothermal activity. And we found phosphate in the plumes of those vapors. And again, methane is usually a product of life forms. So that could be definitely Enceladus and Europa are now considered the most likely location for extraterrestrial life in the solar system. But another product of life form is dimethyl sulfide. Recently, the James Webb Space Telescope has found dimethyl sulfide and dimethyl disulfide in the atmosphere of an exoplanet called K2-18b, which is 125 light years away from Earth in the constellation of Leo. Oh, also, K2-18b has an hydrogen-rich atmosphere and a liquid ocean. And what are those called? We're discovering entirely new classes of world now because of the James Webb Telescope. And those worlds that we call Haitian, not ocean, but Haitian planets, which could be ocean-covered worlds with hydrogen-rich atmosphere. Amazing. And then and then further away from Earth, 244 light years away from Earth, we just discovered just a few days ago large amounts of hydrogen, also some water vapors, as well as tentative signatures of carbon monoxide and sulfur dioxide in the atmosphere of a really hot exoplanet sub-Neptune size called TOI 421b. Now, what could survive in hydrogen-rich atmosphere? Well, several microorganisms, including E. coli, it's a bacteria that commonly we have here on Earth, yeast, can survive, and also archaea. Those can survive and thrive in environments containing only hydrogen gas. So we found that those organisms, they can utilize hydrogen as a source of energy and then can adapt their metabolism to use hydrogen instead of oxygen, suggesting that life could potentially exist in those planets. So you see, it's so fascinating that life could be outside of our Earth. They could be life, and it could travel long distance to possibly Earth. So that could be the origin of UFOs. Nothing is really impossible at this point.
And that is very fascinating. My question is also, because you asked where does the methane gas come from, or where does water or hydrogen, like how is it possible that we find them on other planets? And my question is, as a follow-up to that is, Eric, you once told me that, these organisms or these beings or anything really, it's kind of like a cross-pollination with bees and flowers, in terms of asteroids and planets. Can you touch a little bit about that?
Well, I think Dr. Chris mentioned panspermia, which is that if you go back to what she said about the organism found inside a 2 billion-year-old rock, it means that if that rock were traveling through space and came to Earth and cracked open, then that life would, quote unquote, pollinate Earth. And so it's just like bees pollinating flowers. Asteroids and comets pollinate planets. And that could well be how life got here. In fact, there was an asteroid, a meteorite that was found in Antarctica that came from Mars that some people think had signs of life on it. So maybe life came here from Mars.
So it's very possible that we come from someplace else, or the beginning of us comes from someplace else. But isn't it also possible that we brought these things to other planets via asteroids?
Yes, we could have contaminated other planets. But we now think that life started here a mere few 100 million years after the Earth formed. And if that's true, we were still getting impacts because we didn't have the same atmosphere. And so a lot of stuff got thrown out, and we could have contaminated other planets in the solar system.
Okay, so what do you believe? What do you believe in your heart is to be true instead of all
Well, let's
these?
start with Dr. Chris.
Okay.
Oh, in my heart, I believe to be true, but that's in my heart of hearts, that out of the trillions of planets everywhere else in the universe, that there has to be life somewhere. It has to be life. I mean, we're discovering more and more. And with the James Webb telescope, space telescope, I mean, the last few days have been amazing, and it's going to grow exponential. It's going to be, yeah, that's what I think.
But when you say life, you mean life a as intelligent life?
We don't know. Possibly,
In your heart of
possibly.
hearts. In your heart of
Heart
hearts.
of hearts, far away, trillions of planets, and some really, really far away from us that we cannot even see. Uh, in my heart of hearts, I do think it's very possible. It's very likely, considering the high number of planets. So I do think so. I do think so. Now we need to prove it.
I think it's very important to define what intelligence means.
Mhm.
I've seen some astonishing videos of a macrophage chasing a antigen infection through a petri dish, and it warps and morphs its shape. It senses where it's going. It decides the quickest way to get at it, and it has no neurons at all. And if you look at colonies of bugs like slime molds and things like that, they behave in a coordinated, intelligent fashion. And so even single cell organisms show some kind of intelligence, and collectively even more. So I think if you're saying as intelligent as humans, uh, even so, statistics suggest that yes, at least at some time in the past, there were and probably will be in the future. So I think it's super important when you're thinking about the possibility that UFOs could be ETs. If you want to understand what you're looking at, it really matters to look at why it's doing what it's doing. And so all of the reasons that we have, like they're here to steal our resources, they're here to spy on us, they're here for recreation, they're here to hybridize themselves so that they can propagate their species, they need our water. That's the way we would think of it. They may not think any of those things and probably don't.
Yeah.
So I think that's the sense in which it opens up the aperture of what might be out there and might be happening.
So anything and everything is possible out there. Let's just open our eyes and be open for anything, whatever comes, and welcome it. To me, I that's what I say also in medicine. It's like welcome, welcome body, welcome.
Hmm.
Yeah, and by the way, I want to build on what Chris just said in terms of welcoming. We can't welcome what we don't notice. What if life came here and we didn't recognize it as life? Who says that we would? If it's as different from us as I've suggested it could be, then it's possible life is already here. We just don't know what we're looking at. For example, suppose something ages way slower than we do. Like it lives many millions of years and you can't see it aging and you can't see it moving and you can't see it doing anything. It's like a rock. But if that rock moved once every 1,000 years, you'd never know it moved on its own. Right? So what if life is made of dark matter? Something that we can't see. And what if it communicates using dark energy, something we don't understand? So really, I think it's a lot of fun, but also very useful to free yourself up from our lens at looking at the world and look at explicitly the opposite of what we are. And maybe we'll find some things there.
Mm-hmm. I love that. Speaking of which, can we talk about a little bit, like, what do we need to understand about the human brain before we could even begin to ask questions regarding UFO sightings?
The first thing is the brain is flawed. Our brain has evolved to make the most rapid decisions that are most likely to produce a good result. And our brains stopped evolving about 300,000 years ago. And so those decisions aren't necessarily correct anymore. For example, 300,000 years ago, eating all the fat, sweet food you could get your hands on made a whole lot of sense because you were in no danger of getting fat, but in a lot of danger of starving to death. That's why we eat sweet, fat food and salt. But similarly, our brains, in order to be small enough to get through the birth canal, we can't expand infinitely. And so our brains, actually, for as big as they are, aren't as big as the power that they have because we make good guesses. We take shortcuts. And so that's what leads to optical illusions. Those tease out the errors that our brain makes because most of the time it's correct. So an example in UFOs would be you can't tell the difference between something large, far away, and small, close. They look the same. So for example, if you mistook something that was close for something far and you saw it move rapidly, you'd say, whoa, for it to move that fast 10 miles away, it must be going unbelievably fast. When in fact, it's not. If I throw a Frisbee right in front of your face and you see something the same visual size as a Frisbee, but 10 miles away moving that fast, you'd have a very different perception of what its speed was. So that's a good example of how all of the reporting that's happened is subject to the many errors we can make perceptually. But there's one more kind of error, is that not only do we see things that only our brain lets us, but it's emotional. We tend to see things that we want to see and not see what we don't want to see. And so a lot of the people who have reported UFOs turn out to have a lot of fantasy ideation. There's a metric that you can use for that. And some people just have very rich imaginations. And so sometimes you're seeing things that aren't there. You're not like you're hallucinating, but you fill in the blanks. For example, we all have a blind spot in each eye where our optic nerve punches through the back of our retina. Your brain fills it in, right? It fakes you out into thinking stuff there when it's not. So we see things that aren't there, and we don't see things that are there. And the things we see, we often interpret them incorrectly. So when you take all that into account, the brain would make a horrible scientific instrument.
Yeah, and the brain sees different things. Like if there are 10 different people that look at the same scene, each one of those different person is going to describe the same scene in a very different way and will notice different things. So the brain is biased. The brain interprets. So the brain sees every single scene through its special lens, but it's not an objective sight. It's not really what is. What is it that's really the naked truth? We don't have the naked truth. We only have the truth through our lenses.
Yeah,
And
that's right.
what would the argument be for video evidence?
Well, again, when you look at video evidence, you have to ask a lot of questions. It can be fooled too, because it is a human eyeball looking at it. And so therefore, it's completely prone to the same errors. And in fact, a lot of this flying saucer stuff was faked with plates, exactly exploiting the size distance illusion. So, there you have it. The video evidence, we've seen some like the Tic Tacs that looks very convincing. Some of those Tic Tacs are completely unexplained. Some of them have to do with the size distance velocity confusion based on how far away that was and optical effects with the telephoto lens. So the so-called go fast tic tac actually wasn't going that fast. It was an artifact of the photogrammetric problem, meaning that you had a very long telephoto lens, you had it moving relative to a plane that was moving fast, so it looked like it was moving a lot faster than it was. So video isn't the sine qua non of reality.
It also depends on the angle to which it's videographed. So from one angle, you can see something, and a different angle, you could see something completely different.
Interesting. So there's literally no evidence for anything ever.
Well, no. First of all, in science, it's interesting the way science is. We never say something is true or not true. We say something is true with a probability greater than X. And we never prove something is true. We prove the opposite of it is not true. It's called the null hypothesis. Because, you know, understanding reality is like Michelangelo carving a statue. He doesn't carve the statue. He chips away the pieces of the marble that aren't the statue. And that is the way scientists look at nature. And so we never really prove anything. We just disprove things with a certain probability. Because you know what? The history of science has shown that things that are true are no longer true. Right? How many times? Well, ulcers are caused by excess stomach acid and stress. Well, no, they're caused by bacteria, you know? And we used to think that Newton had defined all of physics. Well, it turned out he didn't, because special relativity and general relativity turned out to be more true. So all of the truths of yesterday are tomorrow's fictions. That's why you'll see scientists be very careful in the way they choose their words.
That's right. In medicine, it's like this all the time. We think we have the answer. We think we have the right medication, and then it works for a while, and then afterwards we can prove that the medication was a mistake, the diagnosis was a mistake, everything was so we completely change what we're saying. Yep.
Yeah, you know, Will Rogers, the comedian, said it best. It's not so much what we don't know that hurts us. It's what we do know that ain't so.
Okay, so the things that we do know is there's clearly evidence for life out there in the universe. Okay.
Well, I wouldn't put it that strongly. I'd
No.
say there's evidence that could be interpreted in one way as coming from life. So we see hints only. We don't have a smoking gun.
Mhm. Okay, so there is potential, there's evidence for potential life out there in the universe, is what you're saying.
Right.
Right.
That's
Okay.
right.
Yeah.
And see it the reason why I'm saying this is because I'm trying to cover a few different areas before we really get into, you know, astrophysics and all that stuff. We're talking about in your book, first you talk about the potential for life, and then you segue into the human brain and how it could fool us many times. And then we segue into, for argument's sake, you basically say that let's say all this stuff that we're seeing is actually true. Like, how would it be possible for this potential life out there that we don't know of or that we haven't discovered yet to even arrive and come over here and say, here we are, pop their heads in and leave again? Which I love. And I think you guys are amazing for doing this. And you kind of play devil's advocate also all the time. You go back and forth, which I love. So before we talk about, you know, the details of it, I was wondering if you could touch on, you know, the Kardashev scale and a little bit of theory and talk about like what it would take for a living organism to physically go from one place to another throughout the universe.
Well, there are two separate questions that are related. The Kardashev scale relates to how a civilization captures and uses energy. So at the planetary level, we have sources like chemical and solar and radiation as energy. And we're at that stage now. So we can make rocket fuel, we can make nuclear engines, and we can travel around using those. That's Kardashev 1. Kardashev 2 is kind of at the solar system level or star level, stellar level, where you can capture all of the energy or a big fraction of it of a whole star through something called a Dyson sphere. And there are various incarnations of those, but they're basically, you put a huge solar cell, much bigger than the sun, around the sun, and you capture its energy, right? And that's what's Kardashev 2. Kardashev 3 is galactic. Somehow you do that on a galactic scale. And, when you look at what space travel requires, if you have a spaceship, as you approach the speed of light, you need infinite energy to actually get there. And so if you really want to travel fast, you have to have a ginormous amount of energy. And that's why Kardashev talked about these different levels. So I think that's the answer to your first question. So I think your second question related to how could you travel really, really fast? And the answer is a couple ways, maybe 20 or 30 ways. Let's just say, for example, what we have today is incredibly slow. You're going like 0.001% the speed of light with our fastest rockets today. We can go, maybe 80,000 miles an hour, something like that with a rocket. That's pretty slow compared to, 186,000 miles per second, right? Which is, light travels really fast. And so to go the distances we're talking about, to get to, for example, Proxima Centauri, which is about 4 light years away, you'd have to travel 4 years at the speed of light. But at the rate that we can do it right now, it's much, much longer, like many, many thousands, if not millions of years, just get to the closest star. So we got to go a lot faster. How do we do that? There are a couple ways of approaching the problem. The one that holds the most promise, and this is really theoretical and may not be possible, there are a lot of things that are possible by Einstein's field equations, like time going backwards and white holes, that white holes depend on time going backwards in a black hole. Those are possible according to Einstein's field equations, but we don't know that they're actually true. So, for example, there's this thing called Albacurie drive, which is your Star Trek warp drive. And the way it works is you have negative energy in back of you, which has been theorized. And we know that there are some forms of energy that push space apart because that's why the universe is expanding. So there's something like that, but we don't know exactly. And then you have some incredible mass or energy in front. And so what happens is you create this bubble of space-time that moves. And the person inside of it isn't moving at all. It's like a surfer riding a wave. And that surfer, the wave is space-time moving them forward. You could travel faster than light in that mode.
But how does that make sense? If the wave is moving, you're moving with the wave at the same speed as the wave, even if you're stationary.
No, this bubble of space-time is moving through space-time, just like a wave moves through the water. It's pretty much the same thing. And so you are actually stationary inside this bubble. And why is that important? Because if you're going to go to Proxima Centauri, you've got to accelerate for a long time. You have to decelerate for the same amount of time. So it really lengthens the time that it takes. Or, and Dr. Chris can comment on this, you have to accelerate in a hurry and decelerate. And if you accelerate and decelerate in a hurry at more than 9 Gs, you're dead. Unless you're a nematode, is that it, Dr. Chris?
Yep.
They can handle
nematode,
tens of thousands.
Roundworm. Yep.
Yeah. So if you're a roundworm, you can accelerate and decelerate a lot faster. So the way that works is, I know the math is really weird and it's kind of mind-bending, but if you bend space-time and you put this bubble in it, it is literally like a surfer. And so the thing is, that bubble doesn't accelerate inside there for the frame of reference of the surfer, if we'll call it, this time-space surfer. To them, there is no acceleration or deceleration. The space-time itself is accelerating or decelerating. And we know that space-time can expand faster than the speed of light because of hyperinflation after the Big Bang. And also, if you look at the rate at which the universe is expanding, the far edges of the universe, from our point of view, are receding from us faster than light from there will ever travel. So we will never, ever know what's there. So we do know it's possible for space-time itself to move faster than the speed of light. There are other methods that are talked about. One is you could get up to a very high fraction of the speed of light by using a Kerr black hole, which is a rotating black hole, as a gravitational slingshot. So if you don't cross over the event horizon and you fall into it in an elliptical orbit, it will sling you out. And you can get up to 0.7, 0.8 C by doing that. Now, you'd have a lot of acceleration, and we're back to nematodes. And then how do you decelerate? That's another interesting problem, because you have to have some force acting in opposition. But you might do that too by getting a black hole to going past and slowing down and having it break you. So anyhow, those are some ideas of how you could get close to the speed of light, or even go faster than the speed of light. And in our book, what we say is they're unlikely, but they're not impossible. And this is an important issue I want to dwell on when we talk to UFOs. When you eliminate the impossible, that which remains, however improbable, has to be true. And I think that there's some very small percent of UFOs, extremely small, that are in that category. In other words, there are things that aren't impossible that we think are like, there's no way that could be true, but they are actually true. I mean, just today, I sent Dr. Chris a video that I got of ball lightning.
Mm-hmm.
Did you get to see that, Chris?
Oh, I haven't watched it yet. No.
Well, I mean, you'd swear it's a UFO. It's this big ball of energy that zips around a parking lot, zip, 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 leaving little trails all over the place. And you go, whoa, what's that? And there have been other cases of ball lightning. And so, there would be an example of something we don't completely understand. So anyhow, just to, tie a ribbon around this, there are, in theories, quite a few ways to travel at near the speed of light. And even exceed the speed of light.
Okay. Now, could you move into time dilation, or just the concept of the more you move through space, the less you move through time? What does that mean?
Well, yes. The first thing to understand is that space and time are not separate. So I want you to think about 3 dimensions here, X, Y, and Z. You can see these X, X, Y, and Z, right? So if you imagine that these are 3 dimensions and they're going chunk, 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 chunk. When I add up, this one to this one to this one to this one, I've got 4 dimensions, because I'm taking 3 dimensions and moving them in another dimension. And when you pull back and look at that, I have movement in 4 dimensions. Mm-hmm. Okay. So what Einstein proved with general relativity is that there is no such thing as pure space or pure time. They're just the same thing. So time is no different than up, down, sideways, forward, or back. It's just forward in a different dimension that you don't see exactly. And so when you're talking about space-time, what is true from a relativistic point of view is that you're always traveling at the speed of light through space-time. If you travel through space, that means you're traveling through time slower. If you're traveling through time only, along the time dimension, you're traveling through space less. But this grows out of a consequence that the speed of light has to look the same to every observer. And since some observers are moving and some are not, the only way for that to happen is if time expands for one. And also, the interesting thing is there's this thing called length contraction. Since time dilates, if I'm going from point A to point B near the speed of light, my time, it doesn't take very much time at all. You watching me, it could take 1,000 years. But since it doesn't take much time for me and I go the same distance, so space times time equals distance, therefore length is contracted. So it's really weird, but the faster I go, the shorter my distance left becomes. And so anyhow, time dilation is, if I travel, and this was our book, The Shadow of Time, that came out of the series we did with you, Nicole, is that we posited a civilization on Earth that came to fore 250 million years ago. And saw the Permian extinction coming, split at near the speed of light, and came back 250 million years later, just, a few days older, and they want their planet back.
Oh, wow. That sounds really
Shadow
cool.
of Time, available now on Amazon.
All right. I
It's
love
a
the
big
plug.
thriller. Oh yeah,
Well,
big thriller.
that actually brings me to my next question, which is if you leave time, how do you come back?
Oh, well, you never leave time. You're always in space-time, and you have what Penrose and others call an event horizon, right? That which you can affect and that which can affect you, right? For example, the edges of the universe can't affect us because they can't get here in time because light is moving slower than the rate at which they're expanding,
So
right?
then can
So
you not?
they're
But you just said they came back in time. You guys came back in time. The characters came
oh
back in
well,
time.
no, they went forward in time. They came back to Earth. They came back in space. So these
Oh, okay.
characters, they actually, spoiler alert, they caused the Permian extinction. A rather juvenile genius version of the species messing around screwed up and caused the Permian extinction, and she got punished. And her punishment was that she couldn't go too far. And so anyhow, so she zipped out into space at very, very close to the speed of light, came back. So she's basically a time machine. And she comes back, and now she's here 250 million years later, and her mom has punished her by making her fix what she broke with the Permian extinction.
So are you saying that you can't go back in time, you can only go forward?
No, not saying that. Again, let's go back to Einstein's field equations, where you can roll time backwards. There's nothing in physics that says time can't move backwards. And we could get into why
Yeah.
we always seem to see it going the other way. And that gets into a little subtlety that I'm not sure many of your viewers could wrap their head around, but I'll go there if you want to at the end. However, the point is that let's take this idea of space-time, right? So we think of moon orbiting the Earth as it's got a lot of angular momentum, and it just keep going around and around and around. But that's not exactly what's happening. The way to think of the Earth is like you take a sheet of rubber and you put a bowling ball on it. That's the Earth. Then you take a marble and you go twing, and it goes around the lip, around and around and around. The orbit is caused by a distortion of space-time created by the mass of the Earth. Energy also creates a warp of space-time because mass and energy are the same thing, related by E equals mc squared. So now let's say I have a big mass, a huge black hole, and it's moving. It's rotating really, really, really fast. Because you warp space-time, when you move something massive, space-time itself moves, just like we said in the warp drive.
Mm-hmm.
So this is why we think a warp drive might be theoretically possible, because we observe in neutron stars and spinning black holes this phenomena called frame dragging, where when this thing rotates, it pulls space-time around with it. And what that means is, if you started orbiting this planet and you went around with it, you'd come back to before you left. Because time is moving.
It's
Time
being
is
dragged.
not, it's being dragged. It's called frame dragging. So the CTC, the closed
Well,
timeline
how much of it is being dragged? Does
well,
that depend on the mass? What does it depend on?
yes, and its velocity.
Mm-hmm.
Because remember, in Einstein's field equations, anything that is mass or energy distorts space-time. So for example, if I go like this and I create pressure or tension or stress, that warps space-time. Energy warps space-time. And so anything that has any kind of energy, potential or kinetic, and any kind of mass will warp space-time. And so you've got something really, really massive moving really, really fast. It's going to warp space-time like crazy. And so much so that you could enter into it if you go, it has what's called an ergosphere, which is like a ring of singularity. And if you don't get close to that, so you get sucked in, you can go around it and come out before you went. So that's what Einstein field equations say.
That's so
And then
cool.
if you wanted to come back into the future, you just go close to the speed of light and you come back. So you could go back into the past and then return to the future. Einstein's field equations say that is theoretically possible. I wouldn't,
What
bet on that in a
happens,
hedge fund.
what happens to your body when you're doing that?
Nothing. Again, it depends on the acceleration. If you get sucked in and you just go around and let space-time carry you like a surf, it's just like
Then
the warp
it's
drive.
just,
So
Mhm.
the main thing that happens to your body is due to acceleration and deceleration. And you can only take, as Dr. Chris said, so much of that.
Oh man. Okay, so you called it a CTC?
Yeah, closed time-like curve. And what it says is if you plot time versus space, what you find is it bends back on itself. That is to say, space-time bends back on itself. And you can see why. I'm taking space-time and I'm stretching it like crazy and I'm dragging it around in a circle. That's where I get a closed time-like curve.
Okay, so now let's bring this back to ETs. How does all of this imply that ETs are potentially time travelers?
See, that's a very interesting question because to travel great interstellar distances and to travel through time is basically the same thing. So everyone assumes that ETs are from some other galaxy or at least different part of our galaxy. That may not be true. It's just as plausible. They either come from our past or our future. So it's just as plausible to say in the future humans figured this out and they're coming back to kill their grandfather, or, now that gets into a whole thing. No one knows how to resolve that paradox, but the Einstein equations don't rule it out. Um, and
And we
so
love and we love Einstein, and he's never been proven wrong. So that's always what we go by, right?
that's right.
What about the stuff that you said that we don't know that we don't know? And maybe we know the stuff that we don't know we never knew. We knew.
Yes, there's known unknowns. Like we
Yeah.
don't know what dark matter is. We don't know what dark energy is. There are unknown unknowns. What's future examples of dark matter and dark energy that we haven't yet discovered that we don't know? And then there's the unknowable. There are things that probably we can't understand and never will. Now, Chris and I have an argument over this.
We do.
Give your point of view,
Tell
Dr.
us.
Chris.
Well, you think, well, yeah, I guess you think that there's things that we will never be able to understand. I guess this is what you're saying. I think that it's possible, it will be possible for us to understand. I mean, I'll let you talk about the cat. I mean, oh, well, I guess I can talk about the cat. You're
Yeah,
saying
say it in
that
French.
you're saying it's tous les chats sont gris, which means all the cats are gray. So you think that you're saying a cat will never be able to tell me that all the cats are gray because it will never be able to speak. So there are limits to what we can do or we can understand. But I think the cat will be able to understand us. A dog can be able to understand us. We can understand the dog. I think as we go, as we progress, we can understand different languages that we didn't think we could understand before. So I'm
Yeah.
optimistic.
I'm not,
You're
because I
not.
think it would be an extraordinary coincidence if human intelligence had just happened to evolve to the point where it could understand nature to its full extent. I mean, that's why, Marvin Minsky said, I'll never teach my cat French when I asked him if we're smart enough to understand nature. And what he meant was we are to the universe what French is to a cat. We're never going to understand it the way a cat's never going to understand quantum mechanics, let's say. Schrodinger's cat's not going to understand Schrodinger,
Yeah,
right?
but we're progressing. We're progressing little by little.
Yeah,
Every year we understand more, we know more. So there
yeah.
is a progression.
I think the point is it's an opinion, and I will
Yeah.
categorize it just as an opinion. The more we learn about nature, the more we know that we don't know. Right now, cosmology is in complete turmoil because of something called the Hubble tension.
What is
There are two
that?
different ways. Well, the Hubble constant is what Einstein called his biggest mistake. When you look at the universe as we see it, it's clearly not stationary, which means something's pushing it apart. And this is where we extrapolate back and there's a Big Bang, right?
Was it you who
And
told me, I'm sorry, was it you who told me that um there needs to be like space is not finite, that obviously like wait, was it you? I'm sorry if I'm messing this up. It's just not my area at all, but I'm fascinated by it. But the fact that it's coming back in, that there are ripples coming back in, means that we're pushing against something.
well, I don't know what you mean by ripples coming back in. There's the residual microwave radiation background of the universe, which
Hmm.
is
From the
energy
Big
left over
Bang.
from the Big Bang. Yeah.
Right.
And it's constant pretty much everywhere. But no, there's no limit as far as we know. People say, well, if space-time is expanding, what's it expanding into?
Or what's it
And
ex
now you get in, yeah, you
yeah.
can't, this is where intuition breaks down.
Hmm.
There are just some things in physics, and quantum mechanics is one, and general relativity is another, where there isn't really an intuitive way of explaining it. You know, it's not like when you talk about the Big Bang, there was a single point and everything is expanding away from that point. No, that's not what's happening. Everything is expanding equally away from everything else. So space-time itself at the smallest scale is expanding everywhere. Now, you try to get your head around that, but that's really what's happening, you know. So I think that when we talk about the Hubble tension, the Hubble constant is part of Einstein's equation. It was a fudge factor, what they call normalization. It's empirical. He just said, well, I need to account for what we're really seeing because theory doesn't explain it. So I'm going to put in this fudge factor. And he called it, you know, he had a term for it, and it just explains the rate at which the universe is expanding. And the thing is, we measure it now, but we don't get the same measurement depending on how we measure it. You can measure it by looking at redshift of certain things, or you can measure it in other ways. And we don't get the same answer. And we're now finding it's not just an artifact, and we have no idea why. And so there are these really bizarre theories out there, like redshift may not be what we think it is. Like maybe light gets tired and loses energy and gets more red the farther it goes. You know, I mean, that's probably not true, but it, in theory, might be true. Maybe gravity doesn't work the way we thought. You wouldn't need dark matter if gravity didn't have a constant rate of decay with space and distance.
Hold on. What exactly is dark matter?
Well, it's an unknown mass that is out there and explains, for example, why galaxies don't go flying apart and why they congregate. When we look at kinetics, like for example, if you have a planet and you have a smaller planet and you know their mass and you know their velocity, or you don't know their mass, you know, you can calculate their mass by seeing how fast this thing is going around, right? Just straightforward kinematic equations. We see that kind of thing, but we don't see the mass. Things are moving as if there's a lot of mass there, but for the life of us, we can't see it. Some people posit, well, is it microscopic primordial black holes? Is it supersymmetric, weakly interacting particles called WIMPs? Is it, you know, we don't know what it is. We can't, it doesn't interact with normal matter in any way except through gravity. And so that's what dark matter is. It makes up a huge chunk of everything in the universe. We see its effect, but we can't see it.
Is dark matter God?
No, you're looking at God. Her name is Dr. Chris Gilbert. He is my goddess, and I worship her.
It's like
But
I'm just imagining this imaginary, this invisible hand doing all kinds of fun stuff that no one can see. It's
Well, like
driving
I say,
everybody
what
crazy.
we can't say dark matter isn't alive.
Well, that's what you just meant. You were talking about how
Yeah,
ETs could be dark matter.
that's right. It could be, we could have ETs is suffusing through our body because dark matter is everywhere. So it's in
Hmm.
our bodies, you know?
exactly.
Who
So true.
knows? Maybe we're like little neurons in a big dark matter brain. Who knows? I mean,
Now
this
that
is
would
kind of,
be.
I'll get to this later, but my belief is about some of these UFO sightings is that they're in the category of something either unknown or unknowable,
Mhm.
right? Like you could, you know, shine a flashlight at a lizard and the lizard would see the light and know that there was a light, but it's not going to be able to know that you're exciting electrons up to a excited state and they're relaxing and generating photons. It's not going to, so it's not knowable what it's looking at. And by analogy, some of these UFOs might be like the flashlight in the frog. We're seeing it. We have no clue what it is, and we will never have a clue what it is. And I suspect that that may be part of what's going on.
But only for a fraction of them, only a fraction, because the other
Very
ones
small. Yeah. And by small fraction, we mean 0.0001% of all the sightings. There are probably a couple dozen that the government says, and the people I know in the government from my past life say, we really have no idea what they are. We've ruled out everything, and we just don't know.
Yeah.
Okay, so let's get into that. If it's not our brain messing with us, if it's not our brain messing with video evidence, if it's not these random potential life that we haven't seen yet, what could it be? You were talking about illusions.
Well, I mean, let's break it down of the possibilities, right? And
So
in the
let
book,
me
we
hold,
go through,
okay. I was gonna say, I
yeah,
was gonna specifically say illusions caused by either our own government or our adversaries,
yeah.
not natural illusions.
Some of them almost certainly are. For example, Chris and I have been doing research on where UFO sightings are, and a lot of them are near the edges of military air bases, but not near the runway. They may be 100 miles, like the one we saw, or we saw videos a few weeks ago at the north end of the China Lake Naval Test Station. And people don't know that they're close to a naval test range. And so when they see something in the sky, they go, oh, I don't know why that is. That's a UFO. But if they see something moving in the sky near an airport, their brain tunes it out. Maybe it shouldn't tune it out, but it does. But when they see it away from an airport, they tune it in. Like the brain is wired to look at novelty and change, because things that are novel are the things that could kill you, because you don't know, you can't anticipate. So you pay a lot of attention. So the fact that a lot of the UFOs are spotted, in places like at the periphery of Nellis or Williams Air Force Base or the China Lake Test Range, or, over a naval flight range over the Pacific or Atlantic, says that some of them probably are government activity.
Like the sphere with the cube inside,
Eh,
the Ryan
again,
Graves stuff.
yeah, maybe.
Did you
Could
look
be.
into that specifically?
Yeah. At one time I had clearances where I pretty much knew everything. And, back then, a lot of these things we just didn't know. We truly didn't know. And
Well,
it's
let's talk
also,
about. Mhm.
go
I was
ahead.
going to say, let's talk about some of the science behind it, like stuff that there are patents for, that exists. Like tell us, give us a few
Yeah.
examples.
Well, I'm going to give you my favorite one, which is a
Okay.
free air plasma, because I did these at Disney. We were working on electronic fireworks because we didn't want to pollute with real fireworks. So it turns out if you take a laser beam and you focus it to a point and it's intense enough, you can basically, this is a crude analogy, create ball lightning or set the air on fire, if you will. You're ionizing the air and you're creating basically lightning. And with really fast mirrors, you can move that thing around really, really fast. And if I did that in the sky, you would swear that thing is moving, at 10,000 Gs. And it is, but it has no mass or zero really to speak of. And so that's a very important point about what could be looking at. Everyone says, well, how much energy you would need to move that fast, or how little mass could you have? Point number two is you don't have to have an engine on board. You can push on things with photon pressure. Even though photons of light don't have any mass, they do have momentum. And so that momentum, when it hits something, will push on it. And so NASA is developing these light sails where either you use the sun or a big laser and you just shoot it at it and the photons hit it and they're like a wind made out of light that pushes. And there are flying saucers that have been levitated on laser beams at White Sands, New Mexico, and other places by a combination of photon pressure and kind of vortex explosions underneath the cup that kind of push it up. So
Yeah, but
microwaves will do this.
What's the maximum height they went?
Well, 80 feet.
Yeah, they couldn't go
But
very far up.
No, but it's just scale, right? You get a big ass laser and a big ass thing, and the math works. The math works. It scales up okay. They did have a problem of doing more because they didn't want to fry the atmosphere,
Yeah.
right?
So you can use lasers to make things levitate.
That's right.
And
You can
that's
use magnetic fields to do it.
Is that what's
People know the Meissner effect. Well, you can levitate.
That's what Billy Meyer was saying, that the extraterrestrials were using the electromagnetic fields of the Earth.
Okay. Look, here's the thing, okay?
Every time I say his name, that's the reaction.
Well, Chris and I know a lot about magnetic fields, don't we, darling?
Yeah, we do. We
'Cause,
have worked a lot with that. Yep.
We for the last 5 years, we've been working and selling magnetic X-rays that are like really, really strong magnets. Like some of the magnets that I use are as strong or stronger than an MRI machine.
Wow.
I mean, and we're talking some serious magnetic fields. And so here's the thing.
What are you guys doing?
If I had superconducting magnet that was a big hollow electromagnet, and I had superconductors, and I put enough stuff in there, like, I don't know, 90 Tesla or something like that, I could levitate you, Nicole.
Really?
Yes.
My postpartum fat ass right now?
Yeah. Might need a little bigger magnet, but yeah. And how do we do that? We have levitated spiders and frogs. And how? Well, most magnetism comes from spinning electrons.
Hold on. Does that not fry the person?
It depends how much you move, because you get a very steep gradient. In a black hole, the gravity well gets so steep that your feet experience much more of a pull than your head. So you get pulled apart.
Right. You mentioned that.
And a magnetic field, they're really steep gradients like that. You can get stuff like that. And I've got lots of broken bones and mashed fingers that show what can happen. But getting back to the frog and the spider, most magnetism that most people think about are due to spinning electrons, because when a charge moves, it creates a magnetic field. So your electron spinning, and that creates a magnetic field. However, anything charged particle spinning creates a magnetic field. So the nuclei and atoms in your body have a certain spin. And this is part of what MRI is, nuclear magnetic resonance, where you torque these things around like a proton inside of you. If you hit it with a magnetic field, it's gonna turn, it's gonna generate another magnetic field. Bottom line is, you can create repulsion effects with diamagnetic type of materials and paramagnetic materials. And that's what water is, and you're mostly water. So bottom line is, if I have a strong enough magnetic field, I can levitate you. And there are certain metals like beryllium. You asked about why spheres. Well, if you were using a magnetic field, you'd probably want to use a sphere to make the effect on the mass predictable. And so you can move it in the way you want to move it, because any slight irregularity off of sphere could be a big problem for a magnetic field.
Okay. Something that blew my mind is when you were talking about turning matter into energy.
Well, it starts with Einstein equation, equals mc squared. Matter and energy are the same thing. They just, energy, if you I have a gram of something, it has the amount of energy in it equal to its mass, a gram, times the speed of light squared. So a teeny bit of mass has a ton of energy. And by the way, that's how nuclear reactors work and nuclear bombs.
I was going to say that was exactly when he split the atom. Is that what he was referring to?
Let's talk about a few ways to generate energy from mass. One is in a fission reactor. So you have enough radiation in a very small space where you're generating neutrons, and the neutrons are hitting other nuclei that are spitting off neutrons. You get this exponential increase. And what happens is the energy gets released as light and heat and other particles. And that's what radioactivity is, right? When you take a certain mass and it decays to a smaller mass, and it converts some of that mass into energy. So that is what we get from atomic fission. In atomic fusion, the opposite happens. You take two smaller molecules or atoms and you mash them together, and they come together, like in hydrogen becomes deuterium or something like that, but some of the bond energy is released as energy. So fission and fusion are ways that we do it today. And in fact, the fusion reactors are trying to get would be self-sustaining because they would generate more energy than they consume. They convert the hydrogen into energy. Now there's another way, matter antimatter collisions.
Oh yeah,
if you take a
crazy.
positron and a electron and you collide them, you get 0.5 mega electron volts of gamma rays out, right? And so what happens is all the mass goes away and gets converted into energy, 100% efficient. You could also use protons and antiprotons, and you could get way more energy. You would get, many orders of magnitude more energy out of that. So those are the three ways: fission, fusion, and matter antimatter. And all of them have been done.
What about using like the cosmic radiation on Mars to create energy? Would that be possible?
Yes. I mean, what Chris is talking about is a fourth way, in that a galactic cosmic ray is really a proton that's been slung out by a supernova or a pulsar or something like that, and it gets spun off. And those things have kinetic energy. And if those hit you, you can deliver a lot. It's like the momentum of a baseball in the size of a proton. So yes, that's another way, but that's actually converting momentum into, taking kinetic energy, maybe turning it into potential energy by charging a battery. But strictly speaking, if we're talking about converting matter into energy, we're not talking about moving matter and harnessing the movement. We're talking about literally converting matter into literally energy in the form of photons, or, well, let's just say photons. Photons could be heat all the way on up to gamma rays.
And all this has been done by our government.
Yes, or by, the matter antimatter. It's really hard. Think about antimatter. If it touches anything, it's going to annihilate, right? And this happens, though, in positron. We generate positrons in a cyclotron, and then we use them in nuclear medicine, right? So we get positron electron annihilations all the time on a really small scale. So that happens. But storing positrons or storing antiprotons in a way that they don't touch any matter is kind of difficult. So the only way to do it is to levitate it in a magnetic field. And the problem is magnetic fields that are strong enough to do that are very, very, very narrow and steep. So you can't put a lot of antiprotons in there. So the problem with doing matter antimatter energy production is you need whopping ass magnets that are huge to store anything appreciably, and you can't ever let them collapse or you get boom.
And so are we storing these somewhere?
I'll never admit it.
No, but what I'm trying to get at is, could you give us a couple of examples of actual craft that has these different types of propulsion or non-propulsion systems?
Yeah, NASA has a program called the NASA NIAC, NASA Innovative Advanced Concepts. And what they've said is, come to us with ideas that physics doesn't say are impossible. If you can prove that physics doesn't say it's impossible, we may fund a small effort to take it to the next stage. And in there, you have at one end of the spectrum, warp drives. They're part of it. And on the other end of the spectrum, things that are more mundane, like ion drives. You have things like light sails that I talked about. You have nuclear weapons that go boom, and the energy pushes on an ablation shield, like all the photons and energy hits that thing, and you just kind of pulse and just keep accelerating by, dropping a nuke in there and letting it go and put another one in. You go pump, 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 and you keep accelerating. So all of those are in there. There are some that are kind of interesting with a fusion rocket. If you take this magnetic field I'm talking about, and you take charged particles in there, and you collapse it really fast, you take the magnetic field and purposely collapse it like this, you can create nuclear fusion, which will throw a whole bunch of stuff out the back that you can use to propel. And all of these things will get you going much, much faster than we're going today. But only like the warp drive has any chance of being, interstellar distances. All the others are to get to another star. Just none of them really are going to get there, in the next tens of thousands of years.
Tens of thousands of years?
Yeah.
You
Well,
mean
I mean,
our
to the next star.
you mean to the next star. You don't mean our technology won't advance for another 10,000
Right,
years.
right. I
Okay.
mean, remember, if it's 4 light years away, do the math.
Mhm.
How far can light travel in a year? A long way. And so we just don't have anything that could get us there, in any kind of reasonable time. So you have to look at some really weird, out of the box ideas if you're even going to entertain that. And there's a wormhole that Einstein's equations allow that. Unfortunately, a wormhole is an example where I've got a black hole where time is moving forward and a white hole where time is moving backward. And a white hole is the opposite of a black hole. A black hole, nothing can escape. No light, no nothing. A white hole, nothing can get in. Everything's coming out all the time. So they're the mirror opposite because time is running in different directions. If you put those at different places in space-time and they form a tunnel, then in theory, you could tunnel through there if you could keep it open. And so you'd need negative energy to do that, which we don't know if it exists. But in theory, again, a wormhole is not impossible. And that would enable you to travel way faster than the speed of light because you're basically taking space-time like this. So I've got a point. Oops.
Oh, we lost you.
Yeah, I know. I've got a point here. I've got a point here. But what if I collapse them like this? So I'm just going beep.
Right.
So I've gone over this distance by warping space-time. And, if I can do that, then I can really go a lot faster than the speed of light. And that would happen in a wormhole.
And so if you're saying that a big piece of mass can create what did you call it?
Well, it's a distortion of space-time.
Yeah. It can frame dragging. What was it
Oh,
called?
that's a black hole that's spinning.
Right, a black hole that's spinning. But you were saying that any type of mass that moves through space drags time and space with it, right?
To a little bit of a degree. It doesn't become significant in any way unless you're talking about a big mass. But anything, light, energy or mass, if it's moving, is rippling space-time as you go. We have these gravitational telescopes, the LIGO, and now they can see these expansions and contractions of space-time with this instrument. And for example, if there's a spinning neutron star or you had two black holes collide, they can see that. And what's fascinating about that is the Big Bang happened, as far as we can tell, about 14 billion years ago. But several hundred million years after that happened, we don't know because everything was ionized and hadn't got to a place where we could see through it. So there's this big opaque spot from the very beginning of the universe that we just can't see because everything was impenetrable for a few 100 million years, but not to gravity. So in theory, these gravitational telescopes would allow us to look back to the very beginning of time, or to be more precise, space-time.
It's so interesting that you just said that because I asked you a question one time. I said, we're always looking through telescopes into space to search for life, but technically, aren't we looking into the past when we do that? Because by the time
We
something
absolutely are.
gets you, so we
That's
wouldn't even
absolutely
be able
true.
to see it.
Yeah, so the most distant objects in space are also the most distant in time.
Right.
So the things that we're seeing that are 13 billion light years away, that's how old they are. So the light you're seeing has been traveling that long, so it's stale.
It could completely, by the time we see it, it's doesn't even look like that anymore, probably.
Well, no, it should look the same according to what we know now. There are some fringe theorists who say it slows down and gets tired.
What does?
That is not mainstream. That is not mainstream.
What slows down and gets tired?
Light.
Is light alive?
Well, now you get, how do you define life? I mean, the short answer is no, not that we know of. But, that's like asking, I've got an electronic pulse going down a neuron. Is that electronic pulse alive? It's energy. Well, it's part of life. So who's to say that photons zipping around aren't part of some photonic brain? Right? I don't know. I mean, in fact, photonic circuits are a real thing. Electronics that really aren't electronics, that we compute and transmit data purely with light, we have those. So I don't know.
I
But
think
it's not useful. It's
right.
not a useful thing to think about right now. I think that the more important point is that people are starting to get a little more precise. Like, for example, here's something that I didn't tell you.
Mhm.
Remember this bowling ball warp space-time? That means that if you're standing on a huge gravitational mass, time slows for you. Time moves slower. And at a singularity in a black hole, time completely stops. So if you're traveling at the speed of light or you're at a singularity, time doesn't move at all from the point of view of an
Someone
outside observer.
looking at it.
Right. So what happens is a mass will slow down time. Okay. So when we're looking at the universe, we got all these masses out there. Some of them are black holes that we don't even see. So light is going by those things, but if light goes by a black hole, it's going to slow down, right? So it's the time it reaches us may be quite a bit longer than when it actually left. And the black hole may actually pull on it and make it redder because, the longer the wavelength, the redder the light, right? So that's the Doppler effect. So when you start to take those things into account, we realize the universe isn't just like uniform jello. It's got lots of lumps in it, and those lumps warp space-time. So it colors the way we see the universe.
What does a lump look like?
Earth, sun, black hole.
Right. So does NASA do shit like this? Do they take this like big massive thing up into space and start, using a vacuum to just get it to just do black hole type things?
No, because we're talking so many orders of magnitude. However, it is true that from time dilation, the way I talked about, it does slow down time. And so the GPS clocks have to compensate for relativistic effects. So we have observed time dilation for real. It's real. We've seen it. So we've also observed time slow down around big masses, and that's real. So, this stuff is true.
But what's interesting
Yeah.
Go ahead,
is
Chris.
what's interesting is to have different points of view. So I think when we were at the SETI Institute, they told us that one of the projects in the future was to have very potent like space telescopes on in different places with different angles, and that would be progress because that would be giving us more of a whole image of what's really going on. Can
That
you
is a
comment on
great
that?
point because a lot of the weirdities going on right now, which are causing all the cosmologists to pull their hair out and look like me, is that they're saying things that shouldn't be true, that both can't be true, but both are true. And that could be because of the way we're looking at it, right? If we had widely spaced sensors, we wouldn't see light being influenced by the same masses. So it might behave very differently. So yes, that is a great point. And if you only look at things through a soda straw on one point of view, you're going to miss a lot.
Right.
So
Okay,
that's the plan in the future. That's what's going to happen in the future. But we need a lot of money for that and time. But I'm very hopeful.
so what you're saying is that not all these UFOs, but a dozen or so of them could potentially be extraterrestrials coming here from a very far distant place.
No, that is not what I said.
How is that not what you said? We're talking about propulsion systems or non-propulsion systems that are not as advanced as they could be for us to get us even one light year away in this lifetime. We said that there are many of them, okay, many of these sightings could be our adversaries creating illusions to mess with like our fighter pilots or people or whatever. We said that that exists out there, but for a dozen or so of them, you mentioned that they're completely unexplained.
Yes, but that doesn't mean UFO aliens, right? Because it's a false equivalence to say we don't understand what we're seeing and we don't understand aliens, therefore what we're seeing is aliens. No. Here is
But
what we would say.
you're saying it's possible.
Yes, it is
Saying it's
possible. We can't
possible.
rule it out. Yeah. So here's the thing. What I'm really saying is we don't understand what we're looking at. Is something we don't understand. And that's exciting. And so when it comes to aliens, we say yo. And Dr. Chris, what does yo mean?
It's maybe yes, maybe no. Yo.
Yo. And that's our
We
attitude. And
say
good
yo.
scientists, yo, the
Yo.
power of yo. And the power of yo means you keep an open mind. I have an open mind that they could be ETs. I have an open mind that they could be atmospheric phenomena. I have an open mind that they could be like the flashlight and the frog. It's something we'll never understand. We can see it, but we have no hope of understanding it. And who says that we have to, right?
Well,
So,
we want to. We want
well,
to.
of course we want to.
We
And
want
maybe
to.
we will. And maybe when humans are augmented with AI together, we can understand more. That's more likely, in my opinion. But here's the thing. Look at probabilities. All we can do is assess probabilities. And in the book, we do this. We do intelligence analysis where we look at, okay, based on everything we know and all of our experience and what all the experts say, in order, what are the most probability? Number one is you can't lump all these sightings into the same category because they're not. We're seeing probably a bunch of different phenomena that aren't necessarily from the same cause. So we can't lump all the sightings of those few dozen that I'm talking about in the same bin. My guess is if someone put a gun to my head, they are absolutely not all the same thing.
Sorry, give me like two sightings that you are familiar with
Yeah,
out
I
of
think
these
there are
couple of
two.
dozen. Yeah.
Well, there's one I saw. I saw a satellite do a lateral maneuver that was like 10,000 Gs. It would have torn it apart, but I saw it. Of course, it may not have been a satellite. I thought it was. No, okay, so there are two.
Where did this happen?
It happened in 1997 in Page, Arizona at 10 o'clock at night after dinner. I went out to lay in the warm desert sand as I had as a child, and I looked up at the black velvet sky studded with a million diamonds. And one of the diamonds moved like a satellite, but it got over me and it jinked left about the width of my thumb. Then it continued. And I thought, I can't have seen what I just saw. That's impossible.
And is that how you ended up here today? Studying all this stuff forever?
No, the way I ended up here today is some of my buddies from CIA said, hey, these people are bugging us to do a show on UFOs. We can't talk. Would you do it? All right. Okay. So anyhow,
so back to the two.
Back on track. What were we talking about?
And
The two sightings.
there is the other one that we saw a video of, or several videos of, when we went to visit, when we went to Ridgecrest. And that's our next expedition. That's the reason why we will go, because we want to verify this with our own eyes. But we only saw several videos of that in Darwin. That was in Darwin, California.
Yeah.
Is that the one you were referring to, Eric?
Yes, that's the one.
Can you describe it? Okay.
No, well, no, I wouldn't say that one because that's near a naval base. And so it could well be some kind of drone that they're doing. I don't think it is, but anyhow, there are two that I think stand out. One happened in 1950, and it was a fireball that moved over Washington, D.C. And it moved it.
Is that episode 1 of Alien Files Reopened?
I don't know, maybe. But that one, there were so many different people that saw that. It was on radar. And you had, people on the ground, fighter pilots. You had a whole lot of people pretty much report the same thing. And so no one has any idea what could have done that. We don't know of any physics, and we don't know of any kind of vehicle that would behave that way. And we had no explanation. They've ruled out pretty much all the other explanations. And that one is really interesting. The other would be two clusters of Tic Tacs that were seen, one in 2004 off the coast of San Diego, and then one in 2014 off the coast of Virginia or Florida. It's down there in the Atlantic flight range. Those were seen by a lot of different people. They were captured on radar. They were captured on infrared. They were captured on HUD cameras on F-18s, and all of the data lined up. So it wasn't like an error in one system. And this gets back to something Chris said. You looked at it from a whole bunch of different angles from pretty reliable sources, and you got the same answer. And things were moving like
What speeds are we talking about? What kind of
well,
maneuvers?
I mean, hundreds of thousands of miles an hour. This thing dropped from low Earth orbit down to the surface of the water in like a second. Okay, so that's 250 miles in 1 second. Do the math.
And that you
Right.
don't think could be an illusion? An adversary playing a trick on fighter pilots?
It could be, but
But you mentioned
there
this
is
one
one.
because you don't believe that it was.
I don't think it was. I mean, because the only thing that I know that humans could generate that would do that would be a plasma under remote control. It could do
Underwater
that.
as
However,
well?
no. See, there's things about the plasma that don't add up. A plasma does reflect radar. It does have a thermal signature. It does have a visual signature. It can move at that speed. And, oh, by the way, without generating any sonic boom or any sound or having any means of propulsion. All the category, we have five, right, Chris? What qualifies as a UAP?
Yeah, yeah, yeah. So very rapid accelerations, decelerations, no visible engine or mode of propulsion, can go from very quickly from air to space, to back to air, back to inside water and back up. So transmedium,
And
uh,
stealth. And stealth.
and stealth.
Yeah. And so those had all of them. And so the thing is, the only thing I can think of is a plasma, and they didn't look like plasmas. I have seen plasmas, and they don't look like that. And also, they generate a lot of static RF and interference and stuff like that. So those two, I would say it's an unknown unknown. Well, it's known in the sense that we don't know what it is, but the explanation could be something we don't even know to ask,
You
or
don't,
something. Yeah.
sorry, you ruled out China or Russia or any of our adversaries?
Yeah, we track what they can do, and we miss it sometimes, like hypersonic weapons. Maybe we'll get it off by 500-600 miles an hour, or what its altitude can do. We make mistakes, and they can get ahead of us, and we don't know. But we're talking, one of the fighter pilots put it this way: this would be technology 10,000 years in the future. And we did interview fighter pilots. And what they all tell us, well, tell them what the one that told us at China Lake, Chris, that we talked to about. We asked him, have you seen stuff? And can you comment on it?
Yeah, and he said he could not comment on it. He could not tell his superiors about it because he would be what would happen if they would laugh at him?
He'd be
What
laughed
was
at
it?
him. And
They
and
would laugh
also,
at
it's
him.
bad for your career to bring it up. But what he said was, we've all seen a lot of things, and we
Yeah,
just don't talk about it. So
yeah,
they are very underreported by pretty damn reliable people. Although I put quotes around that because they still have brains, even though they're fighter pilots.
yeah.
So
Which is a
I
bad
think,
thing, which is a bad thing.
well, it's
You
good and
mean
bad.
that
I
in a
mean,
negative way because your because you
I,
can't
I
trust your brain.
I grew up with fighter pilots.
Hmm.
I spent 15 years of my career on training systems for fighter pilots. I know them very well. And when I saw the guys on Unidentified, the one that Elizondo and
Yeah.
Mellon and those guys do,
Hmm.
it rang true to me. The things that they said, and they had tremendous courage to come forward. Now, I'm not saying they were ETs. What I'm saying is what I think they saw, those pilots that were interviewed and the ones we interviewed, I think it was real. I don't think it was an illusion. I don't think it was our government. I don't think it's someone else's government. I don't think it was an atmospheric effect or anything like that. I don't know what to think. I think it's in that category of the flashlight and the frog. It's something really weird. And as Isaac Asimov said, and Chris alluded to this, science doesn't proceed with eureka, oh, I figured it out, I'm a genius. It's you see something and you go, that's funny. And we're seeing, I believe, a that's funny moment with some of these UFOs.
But some of them, some of our government, they're so compartmented, our government. So it could be extra secret stuff that is not even shared by anybody else in our government.
That
So
happens, and I think some of them are that. I mean, there are these rocket motors. Some of them are like I found like the plasma. They're working on that. And in fact, I brought it up to the aviator at China Lake. And I said, you know, the Navy has a patent on painting an outline of an airplane from a laser on a ship to confuse the missile and the sensors to make them go in the wrong place. I said, it's patented. And he goes, well, that was not a very cool reaction. Like he knows all about it and they're probably testing it there. So some of these things are known. Some are not known, and I would bet, dollars to donuts that a few of these unexplained ones are that, either us or our adversaries.
I mean, this Tic Tac one really sounds like, because okay, you mentioned the one in the 1950s, but also we didn't have the information back then that we have today. So, it could have been something explained.
Yeah.
That was unknowable in the 50s, right? That's not unknowable today. But yeah, okay. I think that's a great place to end this podcast.
Hit that like button and subscribe.